Right now, tonight, your brain is going to do something it never does while you're awake. It's going to turn off the one part of itself responsible for telling right from wrong, real from fake, possible from impossible. And for the next 2 hours, it's going to use that freedom to build entire worlds inside your skull. You will spend roughly a third of your entire life asleep. And for about 2 hours of every single night, whether you remember it or not, your brain will construct vivid, strange, emotionally intense experiences that feel completely real while they're happening, and then vanish almost the moment you wake up. Here's the part that should genuinely surprise you. After more than a century of modern science, thousands of studies, brain scans, sleep labs, and some of the most advanced neuroimaging technology ever built, researchers still don't have one single universally agreed upon answer for why this happens at all. That might sound like a failure of science. It isn't. Sigmund Freud kicked off the modern scientific interest in dreams back in 1900, arguing they were coded messages from repressed desires. Most of that specific theory has since been abandoned. But his deeper insight, that dreams reflect real psychological processes rather than random noise, helped launch over a century of research that's still active today, and that research has uncovered something stranger and more useful than Freud ever imagined. By the end of this video, you'll know exactly what your brain is secretly doing to you every single night, and why one specific brain region has to shut down for it to happen at all. Before we get to why we dream, there's a stranger question worth asking first. How does your sleeping brain manage to convince you that flying or talking to someone who's been dead for 10 years is completely normal? The answer involves one brain region essentially going dark, and we're about to find out which one. Dreaming is most strongly associated with a stage of sleep called REM, rapid eye movement, a phase your brain cycles through multiple times each night, with REM periods generally lengthening as the night progresses. During REM sleep, something genuinely strange happens inside your skull. Brain activity in several regions ramps up to levels nearly comparable to being fully awake. A state researchers describe as the brain being paradoxically active during what looks, from the outside, like deep rest. Two structures in particular light up: the amygdala, your brain's fear and emotion processing center, and the hippocampus, deeply involved in memory formation. At the same time, your prefrontal cortex, the region responsible for logic, planning, and rational judgment, actually becomes less active. This single detail explains an enormous amount about dream logic. It's why you can be casually flying through the sky, and your brain doesn't flag any of it as strange until the moment you wake up. The part of your brain that would normally say, "Wait, this doesn't make sense," has been dialed down. Recent research has also complicated the old assumption that dreaming only happens during REM sleep. Large-scale studies using extensive brain activity databases have confirmed that dreams can occur during deeper, calmer non-REM stages too, moments when the brain enters a kind of partially awake state, even during otherwise quiet sleep. Dreaming, it turns out, is a far broader phenomenon than scientists once assumed. But knowing where dreams happen is only half the puzzle. The real question, the one researchers have spent decades fighting over, is what all of this is actually for. Here's a theory that sounds simple on the surface, but hides a twist most people get completely wrong. You might assume dreaming helps you remember your day better. The real research says almost the opposite. One of the most well-supported theories in modern dream research centers on memory consolidation, the process by which your brain takes fresh, fragile daytime experiences and files them into stable, long-term storage. Sleep researchers have found that memory-related brain activity, particularly in the hippocampus, gets reactivated during sleep, and this reactivation appears tightly linked to how dreams form. In one revealing study, researchers had participants listen to different audiobooks before falling asleep, then used detailed brain activity analysis to show that the audiobook content was measurably reprocessed at the neural level during sleep, direct evidence that recent experiences get actively worked over by the sleeping brain, not just passively stored. But here's the twist. Dreams rarely reproduce a real memory literally or completely. One well-known study found that a majority of dream reports contained some echo of a recent real experience, but a fully literal replay was uncommon. This has pushed researchers toward a more nuanced conclusion. Dreaming likely isn't primarily about storing memories more vividly. It's about processing and integrating them, sorting what's meaningful from what isn't, rather than simply hitting save on your day. Your brain, in other words, isn't a camera, it's an editor. And that distinction matters even more once you see what happens to your emotions overnight. There's a reason certain dreams feel almost unbearably intense, and it comes down to a bizarre chemical trade-off happening in your brain that doesn't occur at any other point in your life. A second major theory focuses on emotional regulation. The idea that dreaming functions as a kind of nightly processing session for difficult feelings. The neurochemistry here is genuinely fascinating. During REM sleep, the amygdala becomes highly active, but at the same time, levels of certain stress-related chemicals, including norepinephrine, drop significantly. Researchers describe this as creating a unique neurochemical environment, one where emotionally charged memories can be revisited and processed, but without the full physiological intensity they'd carry during actual waking life. Some sleep scientists have described this almost like an overnight therapy session, a nightly opportunity to work through fear, stress, or unresolved emotional material in a comparatively safe internal simulation. This gains support from clinical observation. People who experience significant trauma often report recurring dreams that replay elements of that event, suggesting the brain may genuinely be attempting, sometimes unsuccessfully, to process and diffuse those emotionally loaded memories during sleep. Not every dream is emotionally significant. Plenty of dream content is mundane or fragmented, but across large bodies of dream research, emotional content shows up disproportionately often, and the underlying neurochemistry lines up remarkably well with a genuine emotional processing function. Which raises an uncomfortable question. If your brain is quietly running emotional therapy sessions on you every night, why do so many dreams feel like nightmares instead of relief? That's where the next theory gets genuinely unsettling. Here's a strange thought. What if the reason you keep dreaming about being chased isn't random anxiety at all, but a training exercise your brain has been running since long before humans built houses, or even fire? A third influential theory takes a more evolutionary angle, the threat simulation theory, which proposes that dreaming evolved specifically as a safe, low-risk training ground for rehearsing dangerous scenarios. Under this theory, the brain uses dreams to simulate threats, being chased, falling, confronted, allowing a person to mentally rehearse fear responses and escape strategies without any real-world risk. An ancestor whose brain occasionally ran these overnight threat simulations might have had a genuine survival advantage over one whose brain didn't. This helps explain a pattern almost everyone will recognize: how common certain anxiety dreams are across completely different cultures. Being chased, falling, showing up unprepared for an exam, losing teeth. These aren't universal because of some shared mystical unconscious. Threat simulation theory suggests they may simply reflect very old, evolved neural machinery, still running fear rehearsal simulations, even in a modern world where saber-toothed cats are no longer a nightly concern. Threat simulation is one serious theory among several, not a fully settled consensus. But it fits well alongside emotional processing, and both point toward the same idea. Dreaming may be less about randomness, and more about the brain actively preparing you for challenges you might face while awake. Which brings us to the single strangest detail in this entire story. The one piece of neuroscience that explains why none of this ever feels weird while it's happening. Somewhere in your childhood home right now, in a dream you haven't had yet, you might find yourself calmly chatting with someone who died years ago and feel nothing but mild surprise. Here's exactly why your brain lets that happen. It comes back to that reduced activity in your prefrontal cortex during REM sleep. Your prefrontal cortex is responsible for what researchers call reality testing, the mental process of checking whether something makes logical sense. When this region's activity drops significantly during REM sleep, that internal fact-checker essentially goes offline. This is why, mid-dream, you might casually accept that you're late for a job you haven't had in 10 years, without your brain raising a single red flag about how implausible it is. Some more technical, recent research has proposed additional explanations for narrower features of dreaming. For instance, one hypothesis suggests dreaming may help prevent the brain's visual processing centers from being taken over by other senses during the extended visual inactivity of sleep, since unused neural tissue can sometimes get reassigned to other functions. This remains speculative and actively debated rather than settled fact, but it shows just how many angles neuroscientists are currently exploring, even for oddly specific features of the dreaming brain. What's clear across nearly all of these theories is that dream logic isn't a random malfunction. It's a predictable, explainable consequence of specific brain regions turning up while others turn down, a completely different neurochemical configuration than your waking brain ever experiences. Which brings us to the man whose name still gets attached to almost every conversation about dreams, even though modern science has quietly moved past most of what he actually claimed. Here's an uncomfortable fact for anyone who's ever taken a dream dictionary seriously. The man who made dream interpretation famous built his entire theory on an idea modern science now considers almost impossible to actually test. Freud's 1900 book, The Interpretation of Dreams, argued that dreams were fundamentally disguised, unconscious wish fulfillment, coded messages from repressed desires the conscious mind wouldn't otherwise express directly. For decades, this framework dominated popular thinking, especially the idea that specific dream symbols carried fixed, universal hidden meanings. Modern neuroscience has largely moved away from this specific framework. The core scientific problem is that Freud's theory doesn't lend itself well to rigorous testing. If virtually any dream content can be reinterpreted after the fact to fit an underlying wish, the theory becomes nearly impossible to prove wrong, which makes it scientifically weak by modern standards, however psychologically interesting it remains. Contemporary dream research is grounded far more heavily in brain imaging and testable neurochemical models than in symbolic interpretation. That said, Freud's broader contribution genuinely held up the basic insight that dreams are meaningful outputs of real psychological processes, not meaningless static, laid real groundwork for the field. Modern researchers have simply replaced his specific symbolic framework with far more precise models rooted in memory, emotion, and neurochemistry, which raises one final question. If scientists have all these solid evidence-backed theories, why can't they just pick one and call it done? Here's the answer that might frustrate you, and also might be the most honest thing in this entire video. The scientists who study this for a living have deliberately refused to pick just one answer, and that refusal is actually the most scientifically responsible thing they could do. Current scientific reviews consistently describe multiple credible theories: memory consolidation, emotional regulation, threat simulation, creative problem solving, coexisting rather than competing to be the single correct answer. Many researchers now believe dreams likely serve several of these functions simultaneously, rather than one dream serving one single purpose. Recent methodological advances are actively reshaping the field in real time. Researchers have moved from older, general theories based on broad sleep stage categories toward far more precise tools: targeted brain stimulation during sleep, high-density EEG recordings capable of detecting extremely subtle activity patterns, and machine learning analysis capable of finding patterns in massive sleep datasets that earlier researchers simply couldn't detect. Large international research consortiums have even begun building enormous shared databases combining brain activity recordings with detailed dream reports, allowing far more rigorous analysis than any single sleep lab could previously manage. The honest current scientific position is this: dreaming is very likely doing multiple jobs at once, filing away useful memories, processing difficult emotions, rehearsing potential threats, possibly supporting creative problem solving, all while your prefrontal cortex sits largely offline. There's no tidy bow to tie on this, and that messiness is exactly what makes the final picture so interesting. So here's the thing nobody tells you about tonight right before you fall asleep. For the next 2 hours, your own brain is going to do something no waking version of you would ever be capable of doing on purpose. After more than a century of investigation, the honest answer to why we dream is that neuroscience has moved from one confident, sweeping theory to several well-supported ones, each explaining a genuine piece of a genuinely complicated puzzle. Dreaming appears to help consolidate memory. It appears to help regulate difficult emotions in a lower-stakes internal environment. It may help rehearse threat responses left over from a far more dangerous evolutionary past. And it happens through a strikingly specific, well-documented neurochemical configuration, an active amygdala and hippocampus paired with a quieted prefrontal cortex that fully explains why dream logic feels so untethered from reality until the exact moment you open your eyes. What's genuinely remarkable is how much has changed in just the last few years. Researchers have discovered dreaming isn't confined to REM sleep alone. International databases are now combining brain scans and dream reports at a scale impossible even a decade ago. And tools like high-density EEG and machine learning analysis are letting scientists detect patterns in the sleeping brain that earlier generations simply didn't have the technology to see. Tonight, when you fall asleep, your brain will once again spend roughly 2 hours constructing entire worlds. Vivid, illogical, occasionally terrifying, occasionally beautiful, built from a specific identifiable neurochemical state that scientists can now observe and measure. You still probably won't remember most of it by morning. But for the first time in human history, science actually has a real evidence-based idea of what your brain was doing, and why, during those 2 invisible hours every single night of your life.